Welcome to the assignment SBW Overview Trig Ratios of the Solar Eclipse 2024 4.03. Eagle Pass, Texas is set to be the lucky first city to witness the great North American eclipse of 2024, while Sharp, Maine will be the last before it heads to Canada. But hold on to your space helmets. Today we're going to calculate the average speed of the lunar shadow. We're going to use some tables and our trigonomic ratios that we've been learning about. Then we're going to determine the angle you will view the eclipse from using the diameter of the moon and the distance from Texas to Indiana. The first thing that we're going to do is calculate the average speed of the lunar shadow using this table. Since there are 60 seconds in a minute and 60 minutes in an hour, there are 3,600 seconds per hour, which is 60 seconds divided by minutes times 60 minutes divided by hours. We're going to determine the ratio for the diameter of the sun next, but let's go ahead and look at this table. So in Texas, the eclipse is going to hit at 12, 10, and 14 seconds. That's going to be 785 miles from Missouri. So we're going to take this distance and we're going to divide it by the time. Notice that from 12:10 to 12:38, that's 0.48 seconds. Now we're going to go ahead and we're going to go from Missouri to Illinois. So from Missouri to Illinois is 785 miles and then 900 miles. So 900 subtract 785. Let me go ahead and plug this into the calculator here. 900 subtract 785 is equal to 115. See if I typed that in there correctly. Well, it's not letting me type that in there. This might be broken. Since my table's broken, we're going to go ahead and use our calculator. So 115 divided by 0.098 is equal to a speed of 1,173. Then we're going to go from Illinois to Indiana. So let's go ahead and plug in 1107 subtract 900, which is a difference of 207 miles. And then we're going to divide that by the time. So from 12:43 to 12:53. So we're going to say 207, or we can use our answer, however you want to do it, divided by 0.167 is a speed of 1,239 miles per hour. Now we can use a table to determine the ratio of the diameter of the sun to the moon and the distance from the earth in miles. First, let's look at this ratio. So notice that the distance, and we're going to use our calculator here, so I'm going to go ahead and clear everything out. Notice that the sun's diameter is 864,938. We're going to divide that by the moon's diameter, which is 2,159. That's going to give us an approximate ratio of 400. 401 because it's 400.6. So we're going to go ahead and round that up to 401. Then let's find the ratio of the distance from the Earth to the Sun. So the distance of the Earth to the Sun is 93 million. 2, 3, 1, 2, 3. Wow, miles. Okay, and then the distance from the Earth to the Moon is 231,900. Oh boy, look at that. Both of these ratios are equal 1 to 1. So if the moon has a diameter of 2,159 miles and the distance from Texas to Indiana is 1,107 miles, what is the angle you're going to be viewing the eclipse from? Using the diameter as the opposite side and the distance from Texas to Indiana as the adjacent side, what would that angle be? Go ahead and set up this ratio. Notice that I've set up the inverse for you in our calculator on Desmos. In case it's easier for you to see a visual, we're looking for this angle right here. So this is your observation. Notice that the diameter of the moon, so if the moon was right here, the diameter of the moon is 2,159. And then the distance from Texas to Indiana, where you're going to be viewing it from, probably, is 1,107. And since both of these are miles, we don't need to do any conversion. We can just plug it straight into, I forgot to write the 9. We can just plug it straight into our calculator, and it's going to give us the angle which we will be viewing the eclipse from. Nope. I thought that this image from NASA was kind of a cool explanation of how we're going to be viewing it. So what you can see is that the diameter of the moon right here is blocking the entire sun from our viewpoint. So as we're viewing from this angle right here, all we can see is the moon, because the way that it's set up, it's completely and totally blocking the sun. If you have any questions on this writing assignment, please feel free to text me, call me, or send me an email with where you're stuck.